Hey, we're going to try calculating a derivative from a function. We're going to use our limit definition of a function for the first time. So the function we're going to work with is f of x equals x squared, very simple function. And we're going to walk through this and make sure you understand how to use our limit definition for a derivative. So that limit definition for a derivative be f prime of x equals limit as h approaches 0. Sorry, let's get this straightened out. H approaches 0. That's so our 2 points can get really close together. Of f of x plus h minus f of x. That's a difference in two y values. Over x plus h minus x, which we'll just simplify down to h. So we need to make sure we put everything in that we have. So our function is f of x equals x squared. And that is something that we need in the top part. But we also need f of x plus h. So what happens when we move that point a little bit? So we're going to plug x plus h into x squared. So it'll be x plus h quantity squared. And if we multiply that out, it'll be x squared plus 2xh plus h squared. That's a FOIL. So let's go ahead and for our function, go ahead and put that in. So we're going to have the limit as h approaches 0. It's a little redundant to write, but it's important. Of a numerator of x squared plus 2xh plus h squared for f of x plus h. And then minus just x squared for the f of x, and all that will be over just h. Now here you can look at this and tell that there's an x squared and a minus x squared that we're going to mark out of the numerator. So take a look at what's left here. We've built this function, and the idea is that we want to take the limit as h approaches 0. So when I talked to you about taking limits of algebraic functions, the first thing I said was try and plug it in. But in this case, when you try and plug it in, you get 0 on the bottom, which is definitely bad. But you also get 0 on the top. And when we had 0 over 0 for a limit, we talked about somehow reducing that. So let's continue down this path. So let's see if we can factor this thing in any way. So it would be the limit as h approaches 0. Up top, we can pull a single h out, and it'll be h times 2x plus h. And on the bottom, there's a h. And look at there. There's an h factor on top and an h factor on the bottom that we can cancel. So then this comes down to be the limit as h approaches 0 of just 2x plus h. And if we let h be 0, then what we have is just 2x. Now that's our derivative. F prime of x equals 2x. That will calculate slope. And it's called the derivative. Okay, so if you remember, x squared looks like that parabola. This 2x will tell us the slope anywhere we are on that parabola. So in that case, when we try and find slope at x equals -2, we would plug that in. So f prime of -2 would be -4. So when x is -2 on our curve, our parabola, the slope is -4. And while we might not be sure about the 4 number, the negative is definitely good because we can see the function going down over there. And if we try when x is 0, we'll find f prime of 0, we get 0. Okay, let me write a little bit bigger. And once again, we can look at the graph, not that we will always have a graph, and we can tell that the function goes kind of flat there. So there's kind of like no rate of change. That's why it's 0. And at x equals 1, f prime of 1 will be, plug it into the 2x, will be 2. So again, maybe we're not sure about the actual size of the number, but the fact that it's a positive 2 shows us that it should be increasing on that side. Okay. So let's go through another example, but the slope is different at different places along that curve, so we need a formula to be able to calculate it. And we don't want a new formula every time we move. We want a formula that we can change the input and make it work. Alright, the next one we're going to do is find the derivative of y equals square root of x. So we're going to use that definition again. So f prime of x equals the limit as h approaches 0, f of x plus h minus f of x in the numerator all over h on the bottom. So that's our slope formula. Change in y is up top, a change in x on the bottom. The x is moving over h units when we're trying to make that virtually non-existent with a limit of 0. So let's fill things in here. So f of x is given. F of x is just square root of x. F of x plus h is just square root of x plus h. So let's see what happens when we plug those in. So our derivative f prime of x will be the limit as h approaches 0 of f of x plus h is the square root of x plus h, minus f of x will be minus square root of x, and that'll be all over h. So again, we talked about what happens if you plug the 0 in for h. Well, if you do, you definitely get 0 on the bottom. If you plug it in up top, you get square root of x minus square root of x, so in the end you get 0 over 0. So how did we handle that before? We handled it with a conjugate, okay, if there was a square root. So let's see if we got any fancy colors we never use here. I guess the best choice we have might be this purple over here. It looks fun. So we're going to use a conjugate of the numerator since that's where the root is. So we're going to have square root of x plus h. It's a big fat purple. Let's try a smaller one. And it was minus, so we're going to use a plus square root of x. And we'll do the same thing on the bottom. Square root of x plus h plus square root of x. So now we got to kind of push through and make sure we feel good about this. So let's do the work. So it'll be the limit as h approaches 0 of, we got to multiply out that numerator, which will be a full. Square root of x plus h times square root of x plus h will be just x plus h because they're the same term and will not be square root out. And we're doing a full, so I'm not going to write it, but the outer and inner terms are going to cancel because it's creating a difference of squares. So you'll have the same thing for the outer term as the inner term when you multiply up top, but one of them will be positive and one of them will be negative, so they'll cancel. So the last term will be negative square root of x times positive square root of x. That's just going to give you negative x. Now on the bottom, just like when we did the conjugates for finding a limit, let's don't multiply that out by distributing it. Let's just write it down. So we'll have h times the quantity of x plus h plus the square root of x. Because we're trying to get rid of that that h out front, so we don't want to put it with anything else. We want it to be a factor. Now let's go back up top and notice that I've got x plus h minus x. So those two x's will cancel, x minus x, and that just leaves me a single h up top. And without having to write it again, let's realize that there's a factor of h up top and a factor of h on the bottom, so we can also mark those out. So when we clean that up, we come to the limit as h approaches 0 of, everything looks like it's gone up top, but it reduced, so there's still a 1, and on the bottom there's a square root of x plus h plus square root of x. Now there's still a h in the bottom, but because of where it is, when we let h be 0, it doesn't cause any problems. It doesn't make the denominator 0. So when we do that, we get that the derivative here that we started with, f prime of x, will be 1 on top, and there'll be square root of x plus square root of x on the bottom. So that'll be 1 over 2 square roots of x. And that's our derivative function. So that's the derivative, as we like to call it. And it will be good for finding slope. So again, it's a square root function, so it curves and it has different slopes at different points. So let's see here. Let's do the slope. So find slope. So f prime of the 3 points we had, one of them was 1. So when we plug 1 into that slope formula, it looks like we get 1/2. We're going to plug in 2, which I don't know why I did that. That's a bad number for me to pick, but I get 1 over 2 square roots of 2. If you like, I can put that in the calculator. We can just leave it like that, or we could rationalize it, but let's see here. 0.35, if well, let's take it to 4 decimal places, 0.3536. And then the last one, when we plug in 9, we will get 1 over 2 times the square root of 9, so 1/6. So what we can see as we move further away from the origin, the slope is decreasing, 1/2, close to 1/3, 1/6. Well, remember what the square root of x looks like. If you put a x and a y axis here, the square root of x is kind of like a curve. We call it squirt. It kind of flattens out. So it comes up a little quick in the beginning, not super quick, but then it starts to almost look like a flat curve. It keeps going up, but slower and slower. Okay, so a curve does not have the same slope everywhere, the same rate of change. So we need a formula that will allow us to just plug in the location, and then we can calculate the slope at that point. Thank you.